In this lesson, I'll show you how to verify the center of a circle with known points. The question reads, show that the points P, Q, R lie on the circle with its center at the coordinates 4 and 1. Also, is it possible for any other circle to pass through points P, Q, and R? We'll explain that later. The first thing that you have to do to tackle a question like this is plot the points that they've given you. Notice that they've given us 3 points, P, Q, and R, and they're plotted right here, P, Q, and R. To verify that the center of this circle is C, you need to find the length from R to C, Q to C, and P to C. If they're all the same, that means that this circle shares a common radius. Let's go ahead and do that. We'll need to use the distance formula, which looks like this. D is equal to the square root of the difference of the x coordinates squared plus the difference of the y coordinates, also squared. I'll show you how to do R and C, and the same method can be applied for the other two. So let's call this x2 and this x1. We have 4 minus negative 1 squared plus 1 minus 5 squared, and we're going to take the square root of that eventually. Using our calculator, we have 4 minus negative 1, which is 5, that's 25, plus 1 minus 5 is negative 4 to the power of 2 is positive 16. So we have the square root of 41. Now, if the distance between Q and C and P and C is also the square root of 41, that means that it's a common radius. And it turns out that the distance from these two to C is, in fact, the square root of 41. And if you want the decimal version of that, you end up with 6.40. That proves the first part. The second part says, is it possible for any other circle to pass through the points P, Q, and R? Now, to answer this problem, you have to verify that the right bisector of this chord and this chord intersect at 4 and 1. And by doing that, you prove that no other circle passes through these points. Remember what the right bisector is. It's technically a line that passes through the midpoint of another line segment. So the midpoint of this chord is right here, notice, and the midpoint of this chord is right here. We have to verify that it does pass through 4 and 1. Of course, this can be done by finding the equation of this green line and finding the equation of this green line and seeing if the point of intersection is at 4 and 1. Or you can calculate the length of the midpoint of this chord and the midpoint of this chord to the center and see if they're equal. It turns out that whatever method that you choose, it shows that the point of intersection of these two perpendicular bisectors do intersect at 4 and 1. And there you have it. That is how to verify the center of a circle with known points.